Again, another interesting question of evaluating limit, and here limit x tends to 0. This is sine ax plus bx divided by ax plus sine bx. What we can do again? They are giving trigonometric ratios. It means we have to use somewhere this formula: sine theta tends to 0, sine theta divided by theta equals to 1. That is always sure, you know, when you were almost sure, 90% cases. So we have to use this formula. It means we have angle here ax, so in the denominator we need to get ax at any cost. Similarly here we have bx, so in the denominator we need to get bx, right, at any cost. So we have to add in something in such a way that we will get that things. Okay, and you might be saying, hey brother, why don't we directly insert the value of x tends to 0? No brother, see here, maybe sister, when x tends to 0, then it will be like a times 0, so it will be 0, and sine b times 0, so this is going to be again 0, and sine 0 equals to, yes, 0. So numerator we don't care, but denominator we are getting 0, right? So getting 0 in denominator, that's really bad news for us. We'll get some undefined value, undetermined value, so we have to work on that. And yes, we can do it, no problem. See here, limit sine ax, all right. And as I used to tell you from initial stage, I'm telling you, whenever you're not getting the favorable angle in the denominator of your trigonometric ratio, like here sine we have, then create it yourself, all right. So I'm going to create myself. I'm going to write ax from my side and times ax. If I'm dividing, then I need to multiply. That's a very simple rule of mathematics, you know that. And this bx is as it is, I'm writing here bx, and the same thing I'm going for the denominator, all right. This ax, let's write that as it is, and here I have sine bx, and again my dear friend, I don't have angle bx in the denominator. So if we don't have what I told you, create yourself. So let's create ourselves bx and times bx. That's pretty cool, huh? You're creating the word as you need. Okay, so x tends to 0 now. Now see the beautiful things here. We are getting here x common, here also x, you know, so we can get x common here, and here also x, here also x. So x and x will get cancelled when you take the common from both numerator and denominator. So now I'm going to take common x, all right. So x, and then it will be sine ax divided by ax plus b, and this a I'm writing here, okay. And further from here I can take this x and this x, so x is getting common again, and I will be left with a and plus sine bx divided by bx and times this b, all right. And this x and this x get cancelled, and now it's time to insert the values, insert this approaching value. So before that, I have to tell you something. Check out in the formula, angle is tending towards the angle, then sine of the angle divided by angle we have. But here it is x tends to 0. But let me tell you one thing, when x tends to 0, it means x is almost equals to 0, then whatever times 0, you know, so ax will also definitely change to 0, you know, and definitely bx will also approach to 0 in the same time. So I can easily write this limit for the numerator and for the denominator, because we had learned in algebra of limits that we can write the limit wherever we want, you know, just like the normal algebraic rules. So limit. Now in numerator I have angle ax, so I will write now favorable limit ax tends to 0, and it will be now sine ax divided by ax times a plus b, and in denominator my favorable thing is bx tends to 0, because angle is here bx, all right. So it's limit ax tends to 0, a plus sine bx over bx times b, all right. And now let's plug the values, all right. So this thing is going to give us 1 times a plus b, and here this is a as it is, plus this thing is going to give us 1 times b. And my dear friend, take a look very seriously, not simply seriously, very simply, a plus b, a plus b, a plus b, a plus b. So guess what is the answer? Yes, that's 1. Everybody can guess, right? So this is how we need to solve it. If there is any more confusion or doubt or any suggestions, anything you need to give me, then please feel free to comment below this video, and don't forget to like this video and subscribe the channel. I'll be really happy to you. Bye bye.